Well, this is Mr. Precella. The other Mr. Precella is running an errand, filling out a form, and I'm going to start the class without him. So, if you're new here today, by that I mean you weren't here the first two class meetings, you've got to log into Canvas to get started and click on the Math 13-14 course, not the 314. It has the syllabus and instructions on how to start or how to register for My Math Live. You don't register for Pearson using the instructions on the cardboard if you got a cardboard access code from the bookstore. You've got to start by clicking here on My Lab and Mastering, and at that point it'll walk you through what you need to do. A word about the assignments. Up here you see the upcoming assignments. I've had some questions. What if you want to work on assignment 1 again? Well, if the assignment's not listed here, just click on assignments. Click on assignment 1. And I thought it went without saying, but I better say it. At this point, if you don't have 100 already, you would click Improve Score. Okay, once the due date is passed, it asks you, what do you want to do? Improve your score or review and practice? If you click Review and Practice, it's not going to change your grade. You have to say Improve Score, but for me, since I have 100 on it, it would be meaningless for me to click on Improve Score. Another way you can access all the assignments is, if you click on My Lab and Mastering and open My Lab and Mastering, then you have the Pearson homepage, which lists assignments and has a grade book. Your screen would, that was the instructor screen there, so your screen, the assignments would look something like this, and you can always go through and start, click on whichever one you're trying to work on. Again, review and practice or improve your score. This ungraded sample test is just to check and make sure that your computer will run the Pearson monitor system. Okay, when you click on it,
had me download all sorts of stuff. It made me freaked out because it was like flagging it and everything. So.
But yeah, and you gotta. But I can't download it on a Delmar computer. I don't have the authority, so this isn't my personal computer. So IT would need to download it. So if I click here, you would click here. On my home computer, yeah, I click here and it downloads and installs and so forth, okay? If you're using a Chromebook or some computer that won't run the Pearson monitor system, then you'll take your test the old-fashioned way. By that I mean here in the classroom with me monitoring you in person rather than the webcam monitoring you, okay? We'll announce days where we just, that are designed for Chromebook tests or whatever test that your computer you're using, okay? So if you've got to have a computer. There's no way around that, or access to one, okay? Because their tests, homework, everything is done online. So if you can, when you do this, if you see the test problems, you've set it up correctly. Your answers aren't what's important, okay? Now, today we're going to be discussing something called factoring. Are there any questions before we get started? Notice you click on each one of these videos so you can see the problems. And one other thing I wanted to mention, oh yeah, YouTube. Let me see, where are my announcements? We posted an announcement with the link to the YouTube videos for the class. There it is. It's growing. Complex numbers was last Wednesday. No, it was Monday. Yeah, and this was last Wednesday, a week ago today, along with the class introduction, looking at the syllabus and so forth. So all of that's there. And I'm going to go ahead and get started discussing this factoring, unless anyone has a question. Let's see. Let's begin by reviewing something that we've already been doing. Let's review foiling. And you might say, well, why are we reviewing it now? We were doing it the last time. Just humoring me. Suppose we have this binomial, 5x minus 2 times 3x minus 4. The last time we were foiling with imaginary numbers, i's, and we had that extra step where you replace the I squared with what? Does anyone remember? Replace I squared with -1, okay? So, and all it did was change the number in front of the I squared. So foiling this out, we'd have 15x squared. First, outer, is that a minus 20x? Then what? Minus 6x and plus 8. Then combine the like terms. There's nothing to combine with the 15x squared. We can combine the x terms, negative 20x and a negative 6x, negative 20 plus negative 6, negative 26x. I'm doing what my brother would be griping about if he were here, writing small to fit it in there, plus 8. You know what? I may as well just write it like this. 15x squared minus 26x and a plus 8, because I'm going to write some stuff here. What we're going to be doing today is going backwards. Given this trinomial, rewrite it with these two sets of parentheses. That's what we mean by factoring, rewriting as a product, multiplication. If we were going to start going backwards, what we would notice is this first term is gotten from these first two terms, the 5x and the 3x. Now, when you multiply the last two terms, the negative 2 and the 4, that's where you get the last number there. This middle term you get by combining the outer and inner. Once more, let's do one more foiling. 4x minus 3 times, 2x plus 7. Let's FOIL it out. 4x times 2x, 8x squared, right? Now the outer and inner terms are going to combine together to give this middle term. So look at how I'm going to do these outer and inner terms. Right here, these red marks, that's the outer term. 4x times 7x, that's a 28x. And then the inner terms, I'll use black. Is that a minus 6x? See, instead of writing it out horizontally like I'm writing right here, I'm going outer and inner, and then just combining those. Negative 6x and a positive 28x. Negative 6 plus 28. Is that a positive 22x? So what I'm doing is combining the outer and inner. And then what's the last term? Negative 3 times 7, negative 21. So imagine going backwards. If you had this, the 8x squared plus 22x minus 21, and you didn't have those two sets of parentheses, that's what we're going to be doing. The first term, the first two terms should multiply together to give us that 8x squared. These last two numbers should multiply together to give a negative 21. The outer and inner combine to give that middle term. Oh, but not about the foiling. You see how I foiled it? 15x squared.
You're not multiplying 5x times 3x and 5x times 4?
Yeah, that's what I did. 5x times 3x, that's the 15x squared. 5x times a negative 4 is a negative 20x. Negative 2 times 3x is negative 6x.
Yeah, and then what is the other one, the 4x minus 3 and the 2x?
Okay, I'm still foiling. The first, 4x times 2x, 8x squared. Instead of writing it out horizontally, I'm making the little marks. Outer.
That's where I got lost, I think, because you did it a different method.
Outer and inner. Okay? Instead of writing just a plus 28x and a minus 6x, I wrote it like this for a reason. And then I combined them just to go straight to the plus 22x. And then what's the last term if you're foiling it out? Negative 3 times 7, negative 21. Why am I writing it with these marks like this? Well, that's how I'm going to be filling in these parentheses here. What we're going to start doing is going backwards. Given the 8x squared plus 22x minus 31, end up with this. If any of you took the Developmental Math 371 course, this was the last chapter of that course, factoring. What sort of numbers multiply together to give a positive number? Not two negatives or two positives, right? What about two numbers that multiply together to give a negative? One of them must be negative and one has to be a positive. Looking at these last terms, this 21 here is a negative 21. That means there has to be a plus and a minus in these parentheses. Over here, this last term was a positive 8. So that means we needed either plus times plus or minus times minus. There couldn't be one plus and one minus in here because if there were, we would be getting a negative 8, not a positive 8. I'm going to make a table. Let's see. Okay, the first column of this table says second sign. The second column is factored form. If you're trying to go backwards, oh, by the way, when I talk about the second sign, I'm calling this symbol that I'm pointing to right here in front of the 22 the first sign, this symbol the second sign. Like right up here, the first sign would be a minus in front of the 26, the second sign a plus in front of the 8. If you're thinking, well, wait a minute, what if this first number were negative? Then this would be the third sign. Assume the first number is positive. That's an appropriate assumption. If the second sign is plus, the factored form has 2 of the first sign. Okay? So if the second sign is plus, 2 of the first sign. So if you're trying to go backwards here, and your second sign is a plus, then inside the parentheses, you have 2 of the first sign. Fill those in immediately. I need to be clicking on different buttons immediately. That's immediately I've just written there. If the second sign is a minus, like right here, the factored form has 1 plus and 1 minus. Wait to fill those in, because you don't know where the plus goes and where the minus goes. Then one more column. How to get middle term from the outer and the inner. Well, up here we have a negative 6x and an 8. To add a negative and a positive, oh wait, no, I'm sorry. Up here you have a negative 20x and a negative 6x. To add 2 negative numbers, you just add those together. Distinguishing that from over here where we have outer and inner, 1 positive, 1 negative. How do you add a positive number and a negative? You don't add them, you subtract. And once you know how to factor, this table will make sense. That's the sad facts of life, okay? You sort of have to know how to do this before that table makes sense. I still want to write it. Okay. I'm starting with problem 2 because this is a really good first example. Okay? Problem number 2 says, factor the trinomial. Notice that the coefficient of x squared, well, it doesn't need to tell you that. What's the coefficient of x squared here? Coefficient is the number attached in front. The coefficient of x squared is 10, isn't it? Minus 11x and a minus 35.
So that first one that you were writing down was question number 1?
The first one I wrote
the
down.
5x minus 2, the one that you were saying here, weren't you? All of this, was that number 1 or?
Oh no.
It was just to explain the. Okay, I just have the thought, I'm pretty sure.
Oh, no, I'm not going to be doing every homework. I'm not going to do one like every homework problem today. Okay? Let me make sure I've written it down. And in order to factor this, you write out 2 sets of parentheses. What we're doing is something called the reverse FOIL method. Why reverse? Well, we've got to fill in what goes here. And that's what that chart is trying to help you do, is figure out the signs. The first thing I do when I'm factoring, I'll look at the signs. The second sign here is a minus. So the factored form has 1 plus and 1 minus. I'm just going to write out a plus and a minus there. Why am I not filling them in? I don't know where they go. Does the plus go in the first set of parentheses or the second. So I'm going to wait to fill those in.
Isn't it a minus and a minus?
It can't be a minus and a minus, because if you had a negative times a negative, it wouldn't give you a negative 35, it'd give you a positive 35. The last two terms are what give you that last number. Negative 2 times negative 4 gave us a positive 8. What are some numbers that multiply together to give 35 that you know from your multiplication tables? 5 and 7. More than likely, there's going to be a 5 and a 7 right here. One of them positive, one of them negative. But you don't know which one. So here's what I'm trying to show the thought process. I'm going to start with the first number. Numbers that multiply together to give 10. 1 times 10, 2 times 5. Numbers that multiply together to give a 35. 1 times 35, and what's that other pair? 5 and 7. I'm reminded of something that happened in 1992. A lot of things happened in my career. One of them was a student, when I was doing this, said, it was a hostile student. I never have hostile students anymore, but it was a hostile student. I knew it was a hostile student. And he said, "You're just making these things work out." And I thought, oh, wow. I said, that is brilliant. I'm going to remember that. That's what I'm doing. I've got to figure out which of these numbers do I put in here so that I can FOIL it out and get what's right here. I'm just making it work out. Right? I wonder what happened to that student. Who knows? But what I'm going to do is start with the 2 and 5 and the 5 and 7. Usually the 1 and the numbers won't work unless we have a really big middle term. So I'm going to try 2x and 5x. If I started FOILing, if I multiply these first two terms together, will that give me 10x squared? Yeah, 2x times 5x. Now, what about the last two terms? Well, I'm going to try them 5 and 7. 5 and a 7. Now, if I go 5 times 7, that'll give me 35. But again, I don't know where the plus or minus go yet. To get this middle term, I'm going to make these little marks that I did up here. Right here. I'm going to multiply these outer terms. The 2x and 7, that's a 14x. Then I'll make the marks and multiply by inner terms. The 5 and 5x. That's a 25x. I'm on the second line of the table. I know there should be a plus and a minus. Can I subtract these numbers here to get that middle term? Yes. If I subtract 25 and 14, I get an 11. But wait a minute. I need a negative 11. There's a lot of thought going on here. Okay? A lot of thought. In order to get a negative 11, when I subtract the 25 and 14, which one of these numbers would need to be negative? The 25 or the 14? The 25 would need to be negative. The 14 would need to be positive. Can y'all chase those backward and tell me where does the plus go and where does the minus go? Did y'all hear that? The plus goes in front of the 7. That would give me a positive 14. The minus in front of the 5. Now, can I check this other than just typing it into Pearson and getting an answer? Well, yeah. What would I do? I'd FOIL it out. I'd have a 10x squared. That's the first term. Outer is a 14x enter minus 25. 14 minus 25, that gives me the minus 11. And then negative 5 times a positive 7, negative 35.
How did you decide which minus and the plus were? I'm sorry, I'm writing extra notes because I'm
Let's see.
super trying to understand this. It's really confusing.
Okay. Well, okay, I don't have the sign on the 25 and the 14 yet. But I know I need to end with an 11.
Right.
If I subtract them, I get an 11. I want the 11 to be negative. So when you're adding a positive and a negative, you keep the sign of the bigger number. So the bigger number would have to be negative. If you had reversed them, you'd have 25 minus 14. No, that'd give you a positive 11, not a negative 11.
That part I understood. It was how to decide on the parentheses where the minus and the plus.
Oh, okay. Well, if the 25 is negative, where would you put the negative? If you put a plus here, that would give you a positive 25. In order to get a negative 25, you would have to have a negative on that 5.
That makes sense. Thank you
Okay.
for litigating that. I appreciate it.
Now, let me punch this in, and we'll discuss what this option B is in a moment. Now, here, the order in which you write the parentheses doesn't matter.
I was telling her because she's big one. I'm like, it's been over 10 years, so I'm trying to refresh.
So when we say, oh, there's more than one answer, well, you could write the 2x minus 5 first, and then the 5x plus 7. Or you could have typed in the 5x plus 7 first, and then the 2x minus 5. The order in which you write the parentheses doesn't matter.
The numbers were completely different. The numbers that I had were completely different.
Oh, okay, then we'll have to look at that.
Yeah.
Okay? There shouldn't be another...
They gave me the same answer.
Oh.
I don't know what I did.
I bet it has a common factor. Okay, I'll discuss that in just a moment. Now, when I'm here saying it's trial and error, you think, oh my gosh, there's so many possibilities. Imagine if instead of 35, the number had been a 48. How many numbers multiply together to give 48? There's 1 times 48, 2 times 24, 4 times 12, 6 times 8. How do you decide which pair work? Well, what I'm about to tell you can sometimes help you figure out or knock out some possibilities. Let me lift this up.
So basically, factoring was like taking an answer and putting it back into a problem.
Yes,
Okay.
exactly.
Like, that's what
exactly.
I'm seeing.
There should be no common factors other than 1. In the parentheses. What the heck do I mean by that? Well, is there some number other than 1 that divides into 4 and 10?
Yes.
Yeah, 2. You can never have that. Like up here, when I was doing this problem, you can't have something like this. You can't have 2 of the same number in the parentheses. Because what number other than 1 would divide into those?
5.
Yeah, 5. So you can't have the same number in both, same number appearing twice in one set of parentheses. In general, you can't have 2 even numbers in the parentheses. No common factors other than 1. Looking at this first answer, what's the only number that divides into 2 and 5? A 1. What's the only number that divides into 5 and 7? A 1. You can't have 2 of the same numbers. You can't have 2 even numbers. You can't have something like this, 21x plus 27. Other than 1. What divides into 21 and 27? 7 divides into 21, 3. 3 times 7 and 3 times 9. There cannot be a common factor in the parentheses. Okay? And that will help us knock out a few possibilities as we go through these. Pardon me?
I was saying, meaning, like, so the 21 and the 27, because they both go into something there.
Yeah, 3 divides evenly
Right.
into them.
Okay.
Okay? But the big thing is, you can't have 2 even numbers. Okay? Let's see, what about problem 4? Okay, this is a good one. Oh, wait. There is, I should mention this. It's possible that you might try and never be able to get something factored. Let me make up one where you can't factor it. If you can't factor something, you call it either prime, like it does on number 2, or what I would prefer is what it does on number 4. It just says it's not factorable. But before we do number 4, let's try this one. I'm going to show you one so you see that you might spend a lot of time trying to factor something, and it just won't go. X squared minus 5x plus 7.
Is this just an example?
This is just an example showing that sometimes these things won't factor. And I think there's going to be one homework problem that isn't factorable. I think everyone's number 6 is going to be one that doesn't factor. But I wanted to show one that's a little bit easier to get on this one. When I'm factoring, I always look at that second sign. That's how I start off. Looking at that table. If the second sign is plus, you have 2 of the first sign. That means you can fill it in immediately. The second sign is plus, so there. This trinomial is called a simple trinomial because there's not a number in front of the x squared. Those are the ones that are generally easier to factor if they can be factored. Since there's not a number there, what would I need to put here and here so that when I FOIL it out, I get x squared? X and x. Okay. Now the last 2 spaces, what are the only numbers that multiply together to give 7? 1 and 7. By the way, when I say that, I know I should be saying what are the only integers. If you're sitting there thinking that idiot, 2 times 3.5 gives 7. Yeah, I just mean integers or whole numbers. So today when I talk about numbers, when I say what numbers multiply together to give 7, I mean just the whole numbers. Now, there's nothing else there. If I put a 1 and a 7 here, can I FOIL it out and make it give me a negative 5x as the middle term? If I put a 1 and 7, like that student said, the way I'm just making it work out, can I make it give me a negative 5x? I think I can't. I'd get a negative 1x, and what's the other term? Negative 7x. When I add these together, am I going to get a negative 5? There's nothing I can do other than getting a negative 8x. There's no other numbers that multiply together to give us 7. And if you think, well, wait, what if we reverse the 1 and 7? Ain't I still going to get a negative 8x? This is one of those that you say it's either prime or not factorable. Just like a prime number can't be factored into anything other than 1 in itself, a polynomial that's prime can't be factored. Now let me write that problem I wanted to do, number 4. Okay, number 4. Ooh-wee.
What an x squared at the beginning gives you an idea that it's already prime?
No.
Or is that not a rule?
No, the x squared, generally, if it's just an x squared, a lot of times that's an easier problem to factor then. Okay?
It just doesn't necessarily mean it's prime.
It doesn't. Okay. Problem 4. 30c squared plus 89c plus 63. Even though the numbers look huge, I think to myself, I'm an optimist, by the way. I always think things can get worse. And you might be thinking, well, those are some big numbers there. Yeah. But on a bright note, the second sign is plus. I think it's easier to factor if that second sign is plus, because then you have 2 of the first sign. You don't have to wait to fill it in. When that second sign is minus and you're not sure where the plus goes and where the minus goes, I think that's more difficult. So why am I putting plus and plus? Second sign is plus, so 2 of the first sign. Y'all see how I got that off of the table? Second sign is plus, so we have 2 of the first sign. Fill it in immediately. When I make my little marks with the outer and inner, I'm going to want them to add together to get that middle term. Oh well, okay, get started. Numbers that multiply together to give 30. There's a few. There's 1 times 30. Oh shoot! Thank you, oh my gosh. Oh, here, okay. Second sign is plus, so 2 of the first sign. Okay, so I'll put the plus and plus in. Now I need numbers that multiply together to give 30. There's 1 and 30. What about 2 and 15? Is there another pair? Okay, well, I'm going to write 3 and 10 and then do the 6 and 5. So there's a lot of pairs of numbers. Only one of those is the correct pair. What about numbers that multiply together to give 63? Well, 1 and 63. 2 doesn't divide into 63. What about 3? 3 and 21, and I heard another one, 7 and 9. Usually the numbers that are closest together work, but there's no guarantee of that. Okay? But one thing we know for a fact is you can't have a 6 and a 9 in the same set of parentheses. Why? There'd be a common factor. So what I'm going to do is I'm going to try 5x and 6x. I'm going to start with 5 and 6 and see if I can pair it with the 7 and 9. That pen was going dead, and so I'm going to try to go back over the 5x and 6x, which is going to do nothing more than just make it blurry. So let's try with the 7 and 9. Can I make this thing work out with the 7 and 9? If I do, I cannot put the 9 here. Why? If I put the 9 here, what number divides evenly into 6 and 9? Does a 3 divide into both of those? So I can't have the 9 there. So let me try it like this. 9 and 7. I don't know if this is going to work out. How do I find out? You've got to look at the outer and the inner. Let's see if those outer and inner terms add together to get a positive 89x. Let's see. The outer, is that a positive 35x? Or what about the inner? 54x? Are y'all caught up with me? Are y'all following what I'm doing?
Finally,
yes.
Oh, okay. I was going to say, you could say no, but it's consistent. Remember years ago having to tell that to a graduate instructor when he asked me, following what I'm doing. And I said, for the class, no, but it's consistent. Worst teacher I ever had. Does it work out?
Yes.
Yeah, that student from 1992 would be so glad. You had a big impact on me. You're making these things work out. It was something like this, where we just did it. And he sighed, which is just, too passive-aggressive for me. And then said, you're just making these things work out. Now, the order in which you write these doesn't matter. You need one set of parentheses with a 6x plus 7 and one set of parentheses with a 5x plus 9.
C. I just realized that's C.
Oh, shoot. If I put an X, that's the sort of mistake. Yeah, oh my gosh. It's hard as heck to spot.
I was like, yeah.
Oh my gosh. Because it doesn't say you used an X instead of a C. Y'all see that? Thank you, thank you, thank you. There should be a C there. And a C here. Oh, I better do that. C. Okay. So, all right. 5C plus 9, close parentheses. Notice how I'm not hitting a space key. With Pearson here, you never hit a space key. You never use capital letters. Parentheses, 6C plus 7, close parentheses. And check it. Any questions there? Just try another one. Are y'all caught up? Okay. This one is not really difficult, but there is something tricky about it. Okay? Notice, let me make a note before I write this down. Oops. In order to factor a trinomial, it must be in what's called descending order. Must be written with the variables first, the exponents should be in decreasing order. Now, if this is one of those times when I'm up here writing and it's not showing, call out. Order. The constant term, that's the number without a variable, should be last. This is called standard form. Notice how it's c squared c number, x squared x number. Over here, x squared x number, and so forth. You should have it written with the squared term, then the unsquared term, then the constant. Up to this one, number 5.
Can you go back real quick?
You need it written with the what's called standard form. And standard form has the variables written with the exponents in decreasing order. C squared, then C. The constant term is the last thing written, and the constant term is just the number without a variable attached. So x squared x constant. On problem number 5, I don't think that's written in descending order.
Just the way we need it.
You'll have to rewrite it. They sign it? Okay. Don't talk. It's recording. Okay. Are we ready to try number 5? That's 4w squared minus 5. See, it should be the w term should be next. And that minus 5 should be the last thing. So on this one, before you can factor it, you've got to rewrite it. And I'm going to rewrite it just by writing the minus 19w and then the minus 5. You see how I've rewritten it? So it looks in that constant, standard form. W squared, W, no W at all. Let's see if I can do this without putting an X as a variable. Remember years ago I mentioned to a class that if I were ruler of the world, the first thing I would do, the first rule would be
outlaw all other variables except for X and Y.
Yeah.
And Z.
And they agreed with me, and I thought, oh my gosh, I'm joking. If I were ruler of the world, you think I'd be worrying about what variables they're using in an algebra class? Okay, let's see. What about the signs in here? The second sign is minus, so yeah, so we got to wait. I'm just going to put a plus minus right up there. I'll have to wait to fill it in. Now, numbers that multiply together to give 4. Well, there's a couple of pairs. 1 times 4 and 2 times 2. Numbers that multiply together to give 5. 1 and 5. Since there's nothing but 1 and 5, there's no other pair, why don't we go ahead and just put those in the last spots, 1 and 5. And now you got to sort of get a feel for it. Is it going to be the 2 and 2? If I put 2w and 2w, am I going to be able to get a negative 19w? Or should I try the 1 and 4? If I do the 1 and 4, how should I arrange the 1 and 4? Okay, if I put the 4 here, see, there's a lot of thought going on here. And the 1w there.
One thing I notice, if that middle number there is 1 more or 1 less than the product of the two outer numbers, 4 times 5 is 20. That number is 1 less, so I'm going to try the ones with the ones to see if that works. That's why I wouldn't start with that 2. Normally I'd start with 2 and 2, but that's one of the little things I've noticed over the years. It seems like if that number right here in the middle is 1 more or 1 less, there's a good chance you're going to be using 1 for both the first and the last number.
Actually, I started laughing when you started saying that, but actually that's a very good observation.
It's not always true. It's not always true.
So I'll make my little marks. So I have, for the outer, it'd be a 20w. What I'm trying to do now is figuring out, can I make it work out to give me a negative 19w? Like that student said, I'm making it work out. Can I subtract? Now, this is on the second line, where that second sign is minus. So can I subtract those numbers to get a 19? If I subtract 20 and 1, I can get a 19. Okay, so where does the negative go?
Say it louder. Okay, in front of the 5.
You put the minus there, because you would need the 20 to be negative, the 1 positive, like that. So just sort of trace the minus sign going backwards.
1 minus 20 gives negative 19.
And if it's been at somewhere along the way, you've done this before, but I don't assume you remember every bit of math you've ever seen. If you don't remember doing this, it's going to take more work than some of the, oh yeah, I did that last semester in developmental math 371. Okay?
Right.
Huh?
And it's going to
Yeah,
and it's going to take practice.
yeah, but by no means, how do I say, the people that have to work on it harder usually do as well, if not better, than the people, oh yeah, I know all of this. Okay?
Y'all want to FOIL that out and make sure it gives back 4w squared minus 19w minus 5?
Well, we'll just FOIL it out verbally. 4w times w is 4w squared. Now the outer would be a negative 20w. The inner would be a positive 1w, so that is giving me a negative 19w. And then negative 5. Oh, by the way, I should have mentioned this. This factoring stuff that we're doing here is some of the stuff that's going to follow us all semester long. The complex numbers and square root stuff we did in the first 2 assignments,
Well, the complex numbers, reducing square roots will follow us all semester.
But
what was the other one?
w minus 5. Let's do number 6. Don't panic when you see it.
No, I'm not panicking.
Oh, okay, good.
I'm too exhausted from panicking.
Is it in standard form, or am I going to need to move stuff around? It's already in the standard form. 15x squared minus 7x plus 3.
Oh, I like this one. We're not going to have to make a decision about signs later on. We know what the signs are going to be inside those parentheses. If it's factorable, we know what the signs are going to be. That's helpful.
And by him saying we know, he doesn't mean just he and I. Y'all should know too. Second sign
plus, you have 2 of the first.
Right. So I'll put that in, negative and negative. Oh gosh, numbers that multiply together to give 15. Do you see why I said you've just got to know your multiplication tables? 1 and 5, 3 and, 1 and 15 maybe. I don't know my multiplication. It's 3 and 5. Numbers that multiply together to give 3. Yeah. And we've already discussed that numbers. We mean those whole numbers or integers. Okay.
Have you mentioned that you can't have a common factor inside parentheses?
Mm-hmm. Okay, so I'm just going to, you know what?
Well, you know.
1 and 3, so I'm just going to put the 1 and 3 there.
That's the only thing that's going to give you a product of 3. 1 times 3, so.
Now, let's start with the 3 and 5.
Or if you what do y'all want to start with? Do you want to start with the 3 and 5 or 1 and 15? I'd start with the 3 and 5. Okay, I generally start with the pair that's closest together, unless I have a feeling that's not going to work. Okay.
Oh wow, Tim, that's incredibly helpful.
But the 3 and 5, I know. Could I put the 3 here where I'm pointing? No, because I'd have a common factor.
Where you're pointing? Oh wait, I didn't see where
you see where I'm pointing?
I had my hand. I was looking at this.
Okay, so we can't put the 3 there, which means if we're going to try 3 and 5, let's put the 3 here and the 5 there.
Okay. Now, is this going to give me a negative 7x? I would have a negative 5x and is that a negative 9x? Is that giving me a negative 7x? That's what I want. Yeah, it's giving me a negative 14x, isn't it? So I'm going to put a big X through that. That doesn't work.
We know the -1 and -3 aren't going to change. If it's going to be factorable, you got to We'll have those two minuses and 1 times 3. Well, 3 and 5 don't work. So what are we going to try? 1 and 15. Can I put the 15 right here?
So it would have to be a 1x here and a 15x there.
Is that going to work?
Is it going to give me a negative 7x in the middle when I FOIL it out? No, I'd be getting something huge like a negative
45? I mean 46?
46x? So there's no other possibility. So what am I going to list? What am I going to choose as my answer? Okay, prime or not factorable, whatever you want to call it.
But they're saying the polynomial is prime. You select that.
On number 4, they said not factorable. But,
it just depends on who was programming the problem.
Nope.
8.
This is number 8. Are y'all caught up with me? Are there any questions? What about way over there in the peanut gallery?
Yeah, there.
Any questions? Oh, wow. Okay, if I go like this, I can see people that I can't see when I'm up here. Okay.
I think on Monday I'm going to try to remember to turn some of the chairs facing this screen here.
But we don't get in here.
Oh, you're right.
Last semester we'd get in here, way before the class started, but
now
Tim, I got to write the problem down.
Oh, well. Okay.
5b squared minus 7b minus 6. Well, I'll draw my 2 sets of parentheses. Oh. And
what do we know about the signs? Yeah, there's going to be a plus and a minus. The last sign's a minus, so you need a plus and a minus.
So I'll wait to fill them in. When I make my little marks like this, I'll be subtracting to see, can I get a negative 7? Okay. Not a lot of numbers that multiply together to give 5. 1 times 5. Numbers that multiply together to give 6. There's 1 and 6 and 2 and 3.
Well, you can fill in the first pair, 1b and 5b. That's the only possibility.
Or 5b and b, however you want to write it.
It doesn't matter.
So, you want to try the 1 and 6 or the 2 and 3? I would try the 2 and 3.
If you're not sure, I always start with the pair closest together. Unless I notice, 5 times 6 is 30 and I have a 29 right there. Then I'll try the 1 and 5 and 1 and 6. But, hey, this is looking good. Do y'all see it? Okay. For some reason, I thought this was going to be prime again.
No, there's only one. I told you a while ago, number 6 is prime. That's only one prime. Okay?
Maybe I should go shuffle the order of the problem.
It's not as easy as you think, Tim.
You can't.
Because someone's clicked on them, so at that point, teachers can't do anything.
Outer and inner.
Can you see my pink pen?
And remember, we want a negative 7b.
So can y'all sort of chase those? Go backwards.
V, not W.
Oh, why did I put it? V. Okay, earlier there was a W and I put X. I think, or it was a C and I put X. Yeah. Okay.
Okay, wait, so you're saying put the negative in front of the 3, or did you say use right here? What are you saying?
I'll give you a hint. The bigger number,
it's going to have to be negative.
It's going to have this sign.
Okay.
I agree.
Then I'd have a negative 10 and a positive 3. That would give me a negative 7. You'll see how I decided on putting the negative in front of the 2? I was listening to y'all out there saying it. That's what I did. No,
Negative
seriously.
10v.
When you're
Positive.
subtracting numbers like this, the bigger number should have the sign, that middle sign there. So,
How did you know whether to put the 2 and the 3 there?
oh, it was just, you could have tried it the other way, but it wouldn't have worked if you put the 3 and 2. There's no common factors other than 1 here.
So if
Okay?
you put the 3 there and the 2 there, it would have been a totally different answer?
Yes, let's, okay, just to illustrate what you're saying. V, 5V. If we had tried it like this, the 3 here and the 2 there. Why did I go 2, 3? I just had the 2 written first.
That was just
Okay?
lucky.
That was just luck on my part. Okay? Because look at it this way. Are we going to get a 7V there? We'd have a 15V and a 2V. Can I subtract those to get that 7V? No. Sometimes it's not clear. Well, heck, sometimes this whole table ain't clear. It's clear to me. I don't know if it's clear to y'all. But if that second sign is minus, you're subtracting the outer and inner in order to get that middle term. If I subtract these 15 and 2, I'm not going to get a 7. Okay? So, the one that actually works is the V minus 2 times 5V plus 3.
V minus 2 times 5V plus 3.
Oh, and if this is your first day in here, if you're moving from another teacher's class, your other teacher might have separated. For 80 minutes we talk foundations, for 80 minutes we talk college algebra. Here we start discussing algebra and we go from there. We're not separating it. Okay?
If you get a problem wrong, you got to meet the prerequisite to move on. What is it, 80%? So if you get a problem wrong, you say similar question and rework it until you get it right.
Is that like 5 times on question, I think 14 or something on the complex numbers?
Oh,
good.
Number I think number 14 might have been the messy. They multiply above and below by the conjugate of the denominator.
Yes. What's
Okay.
the next one?
I got it.
I want to define something.
Uh-oh. Wait a minute. Okay. Move it up.
Okay. Now, I'm going to discuss something called a quadratic equation. In algebra, an equation is a statement that has an equal sign in it in the original problem. Okay? If you just stick an equal sign as you're doing it, that's not an equation. Like problem number 8, is there an equal sign in the original problem?
Say no.
Say no. That's not an equation.
An equation has an equal sign in the original problem. Like number 10.
It says solve the equation for S. Okay? Let me write my definition.
Yes. Right, your
A
definition.
quadratic equation has a square in it. I'm going to say can be written in the form ax squared plus bx plus c equals 0. An equation must have an equal sign.
Where a can't be 0. A, b, and c are real numbers, but a can't be 0 because 0 times x squared is 0. You must have a variable squared as the largest exponent in order for an equation to be quadratic.
Do y'all remember solving equations where there were no exponents in them. That's the first thing done in an algebra course. Your Algebra 1, the first thing you do is combine like terms, then you solve an equation. It's called, starts with the L. A linear equation has no exponents. If there's an x square in it, or a square I should say, then that's a quadratic equation. And we're going to discuss how to solve a quadratic equation using this factoring stuff.
So if you've forgotten it, you'll get a refresher.
Yeah. How to solve a quadratic equation by factoring. There's actually a whole lot of different methods, and we'll see different methods on the next class meeting. Today we're only doing factoring. First step. The first step is usually done for you. Write the equation in standard form. That's that x squared x constant
with a 0 on one side.
Equals 0 with a 0 on one side. Second step, you factor. That's when you do, okay, second sign is plus 2 of the first sign, what we've just been doing. And once you've factored, set each factor equal to 0 and isolate the x. It may have been a while since you've been solving for x, and if so, that's okay. You'll pick it up quickly. We'll review it as we go through these. So, 1992 was a big year in my math professional career because it was that same year that the students said, you're just making these work out. And then the other student, the waiter at Bamboo Garden, do y'all remember what he told me? His math teacher was an idiot. He told him to study the instructions. And it was, oh, well, you know, you sort of got to do that, you know. And I could tell then when I started taking up for his math teacher, this is another one of those idiots. And he walked away in disgust. But let's look at how the instructions vary from, you see, on problem number 10, it says solve.
No, number 8, it just says factor complete.
And when you have your answer then is 2 sets of parentheses. If it says factor, okay?
But
if it says solve, your answer is going to be numbers, okay? So
notice here for the answer, it says S equals, the variable equals, and it says to use a comma to separate the answers as needed.
And so studying those instructions is sort of important. How do you know? And that happens all the time. Students, last semester, good student, missed all these problems on the first quiz. And I was like, what the heck's going on? And so I was looking through all this work, and well, everything that said factor, he went ahead and actually solved it. No. When it says factor, you just write the parentheses and stop. Well, you fill them in, okay? Number 10, let me write this one down.
Oh, this one's pretty good.
5s squared. Oh, shoot. Plus, back in the olden days when we had to write, you know, make the test problems and type them up and stuff, I remember figuring out never have an S as a variable. It looks like a 5. If I wanted the students to fail a test, all I had to do was put a lot of S variables on the test. Okay? Huh? But now I don't have any control over that anymore. Okay? If I were writing this problem myself, it'd be an, guess what variable? That's my rule. If I'm going to be ruler of the world, the first thing, only X's. Okay? None of these S's. Y'all see my 55 squared plus 225? Is that what it looks like? Okay? Those are my S's. That's a 5. Well, it needs to be written in standard form. That standard form, x squared x constant equals 0, that's already done for us.
I have a solution for your little S dilemma.
What?
Little T.
Huh?
Little, like it would be like with you doing a Z when you put the little
Oh,
cross,
yeah,
little
that's
cross
in,
and a S.
oh gosh.
That's what I do.
Oh, so you just put a little,
A little tiny little cross. Yep.
wow, that is a good idea.
But then you have
And now I'm wondering if you can teach this old dog a new trick. Will I remember to do that or not?
No,
Okay.
I'm pretty sure you
Okay, I'm going to draw my two sets of parentheses. Second sign is plus, so would it be 2 first? Let me go ahead and write out numbers that multiply together to give 5. 1 and 5. Numbers that multiply together to give 21. 1 and 21, 3 and 7. I'll draw my parentheses. So what did we decide about the signs here? Yeah, both plus. Second sign is plus, so 2 of the first sign. So I'll say 1s and 5s. Wow, I like that. Well, it's up to y'all to figure out what are we going to use for 21. 3 and 7 or 1 and 21? 3 and 7. Now, how should I arrange it? Like if I put, can y'all do this in your head? If I put the 7 here, 7 and 5 would give me a 35. I don't think that's going to get me a 22.
Notice the 2 pluses, you're adding everything. If you put that 7 there, you have a 35. That's too big for the 22. So if it's factorable using 3 and 7, it better be this way. And is this going to work? Am I check
making
the
it
outer
work
and
out?
inner.
We would have a 7s and a 15s.
Is that giving us what we need?
Yes.
15 plus 7, I agree. That's giving me a 22s.
So this part here, sometimes students ask, what do you do with that? That's just how I'm checking and making sure this is the right factored form. Okay? So have we factored it correctly? Yes. So one more step. Take each one of those factors. This is the new step that you weren't doing on these previous problems. Take each set of parentheses, each factor, set it to 0 and isolate the x, or what this case s. So I take s plus 3, set it to 0, and 5s plus 7, set it to 0.
You remember?
And yeah.
Wait, so
This is the new step. Since you're solving an equation. Huh?
You just drop the parentheses and just
Uh-huh.
equal 0.
Yes. Drop the parentheses and just write what's inside it. That equals 0. 5s plus 7 equals 0. Now, do y'all remember how to go about isolating a variable? What would I need to do to get this s by itself? Subtract 3. You do the opposite operation to both sides, beginning with addition and subtraction. Like here, I'd subtract 3.
Why are we subtracting?
I'm isolating the variable.
If you subtract, think of that equals as a scale. If you take away 3 pounds from the left side, you got to take away 3 pounds from the right.
You're trying to get the s, or the variable, by itself.
And you do that to both.
Uh-huh. So, subtracting 3 would give me just s equal negative 3.
It's like as you're saying it, I'm like remembering.
Oh, okay. Opposite operation beginning with addition and subtraction. Like right here on this one. To get the s by itself. It's more involved because of that 5. But you start off doing what to both sides? The opposite of adding 7, subtract 7. So we have 5s equals negative 7. Now this 5s is 5 times s. What's the opposite of times? Divide. Divide both sides by 5. We're going to have a fraction on this one. And I guess I'll just write it s equals negative 7 over 5. We have two numbers, negative 7 over 5 and negative 3 is the answers. What we're doing there is called solving a quadratic equation. Someone asked, what did you do in class today? You could say factoring, or you could say we started solving quadratic equations. You'll impress people.
That sounds smart.
Okay. So I'll come over here.
Do you combine those two numbers?
No, you type them both in.
If you plug in what were the
S equals
answers?
Negative 3 and negative 7 over 5.
If you plug in negative 3 here and here and simplify it, it's going to make the left side equal 0. If you plugged in negative 7/5 wherever you have a variable, it'll make the left side equal 0.
I wouldn't want to do that.
How would it
Oh,
be?
by the way, there's a mark right here, and I don't know why that is. I think I was just underlining the second sign.
Right. I'm not sure.
It's just supposed to be a plus, okay? But there was a mark there. I think I was pointing to the second symbol, and it looked like a plus minus.
So we have negative 3, and then we got to type a comma, and negative 7 over 5. Any questions there?
You know, let's do number 11.
11.
Okay. Number 11. Is it in? Oh, more S's. Okay, that's practice for me to put the little mark. S squared plus 5s equals 14. And here it doesn't say solve, it just says solve. It doesn't say quadratic equation or anything like that. Maybe the other one didn't. But if it says solve, you've got to end up with just answers.
Numbers.
Numbers, I mean. If you end up, or if it says factor, that's when you have the two sets of parentheses, okay? You can go now to Bamboo Garden today and tell him, my math teacher's so smart. He told me to study the instructions for the problems.
I'm sure that waiter isn't still there, Tony.
I know,
You're talking 31 years ago.
Yeah, I know. Mm-hmm. Yeah. Okay, looking at the little outline. How to solve a quadratic equation. It has to be written in the standard form. S squared, x, constant, equals 0. There has to be a 0 on one side. Is this one in standard form? No. So I've got to have a 0 here instead of this 14. What can I do to get a 0 there? Subtract 14 from both sides. Okay? As we proceed and do more and more of these, I'll just start doing this, which means move that 14 over and change its sign. Okay, so we have s squared plus 5s minus 14 equals 0. This one's actually going to be easier to factor because there's not a number in front of the s squared. You'll just put s and s. Now, numbers that multiply together to give 14, I'll give us one pair. 1 and 14, what's the other pair? I'll draw my two sets of parentheses. And,
We know S squared.
yeah. But what if, okay, I'll put S and S. You see?
Hey, we didn't mention the signs. What are we going to have inside these parentheses?
A plus and a minus. Did y'all hear that? The second sign is minus. So one plus and one minus. Now, when there's not a number in front of the S squared, it's almost obvious which pair of numbers is going to work. Which one do you subtract to get a 5? The 2 and 7.
A trinomial, this thing is called a trinomial. There are 3 terms. A trinomial where the leading coefficient is a 1. You just have the variable squared. It's called a simple trinomial because it's simple to factor it.
Yeah,
You
I've already
choose the pair
I've
that
already
adds
told
or
him that.
subtract. Oh.
But the first one I did was one that was prime.
Oh, you're joking.
Yeah, so for them, the simple trinomial is not an easy one, but it should be. Okay. How do I arrange my plus and minus to get a positive 5? Y'all hear that? Positive 7, negative 2. You see it? Much easier to factor.
Okay.
Hmm?
I'm finally getting that part.
Oh.
Show your little things,
Oh.
Tony. Show the outer and inner.
You see, we'd have a negative 2s and a positive 7s, giving us a positive 5s.
Negative 2 plus 7 gives me a positive 5.
But do we just type these two sets of parentheses in and say we're done? No. We're solving. So that's where you take each set of parentheses, the s minus 2, isolate the s, and then the s plus 7, isolate the s. So the s minus 2 equals 0. How do I isolate this s?
Plus 2.
Add 2 to both sides. I'll say plus 2, plus 2. So the first number I'll type in is a positive 2. And what about the second one? Negative 7. So we have s equals 7 minus 7. Is that a... So positive 2 and negative 7. It doesn't matter the order in which you type those in.
I should mention, some of y'all, when you saw this solving linear equations like this, your teacher may have transposed. Your teacher may have said, oh, I want to move this term over to the other side. I'll move it over and change the sign. They may not have shown that step right there. But
And I'll get to where I'm not showing this.
yeah, it'll get to where we'll just
I'll
be
just
transposing.
draw
Move
the
that up,
arrow.
and then the 7 becomes a negative 7.
So 2 and negative 7.
2 comma negative 7. Number 12.
Okay. Number 12. Oh, wait. 12t. Oops. Plus t squared plus 35 equals 0. Okay. Is it in the standard form we need it in? No. The t squared should be first, shouldn't it? And look at what I did as I was writing it down. See, you'll see what I marked down. I put square, but it wasn't 12t squared. It was 12t. And let's see, I'll write it in blue. It should have the t squared first, then the 12t, and then the 35. Is this one of my brother's simple trinomials? Well, yeah. Why? Because there's not a number in front of that t squared. We don't have to try to figure out numbers that multiply together to get blah blah. Let's see. Numbers that multiply together to give 35. We have to know those. And which pair of numbers do y'all think it's going to work? Or it's going to be? Huh? 5 and 7? Is that what I'm hearing? So I'll draw my two sets of parentheses and y'all can tell me what signs I'm going to use. Second sign is plus, so 2 of the first. You'll see how we don't have to worry about a number in those first positions. Just put T and T. Five and 7. And could y'all FOIL that out and convince yourself I've done it right?
Yes.
It'd be T squared. Then we'd have a 7T and a 5T. That gives me the 12T. And then a plus 35. Now, set each one of these to 0. And isolate the T. Sometimes students tell me, oh, I can get the T equals without writing anything down. Do I have to show all the steps you're showing? Well, again, your goal and mine are different. Your goal is to get that answer. Honestly, not by using photomath or an app similar to that. Let's see. What are we getting as my first answer? -5. And I shouldn't say first, but it's the first one I'm writing down. Okay? And because order doesn't matter. So a -5 and a -7. So -5 and -7. -5, comma, -7. Or -7, comma, -5, however you want to do it. Okay. Notice, if it says solve, that's when you have the numbers as your answer. If it says factor, that's when you have the parentheses as your answer. Okay. Let's do this last one here. The hardest one, last one, so it's got to be the hardest, right? Let me see, number 15. Okay.
Not on this one, but on the other.
Oh, well, let's...
14.
Yeah, 14 was? Oh, okay. Well, this one might be the hardest. This one might be the hardest this time. This one might be the hardest.
On this one, probably.
Because those numbers are sort of big, 42 and 30. 42b squared plus b equals 30.
-30.
Did y'all hear that? You got to get a 0, so subtract 30 from each side. And we have 42. Oh, wait. Y'all can't see what I'm writing here. Let me change. Okay. So we're subtracting 30. Oh, gosh. Let's go ahead and write out the numbers that multiply together to give 42. There's a lot of them. 1 times 42, 2 times 21, 3 and 14. 4 doesn't divide into it. There's another pair of numbers I'm missing. 6 and 7. Now for 30, a lot of numbers. Well, not a lot, but 4 pairs. Again, just sort of got to know those multiplication tables. If you don't know that 5 times 6 gives 30 or 3 times 10, it's going to be very difficult. Okay. Second sign is minus, so what am I going to put? A plus and a minus? Oh gosh. I guess I'll just I'm going to start with the 2 pairs closest together, the 6 and 7 and the 5 and 6. So I'm going to write down 6b times 7b. Oh, that looked like a, yeah, 6b and 7b. I'm going to try pairing it with a 5 and 6. If that doesn't work, I'll try a 3 and 10, a 2 and 15, a 1 and 30. I'm going to try the 5 and 6 first. If that's going to work, I can't have the 6 here, because if I did, I'd have the same number, a common factor of 6, wouldn't I? So I'm going to try it with the 5 here, and the 6 there. Y'all caught up with me? Now I'm going to make the little marks, and that's when I'm actually seeing, am I going to be able to make this work out or not? We'd have a 36b and a 35b. Can I subtract those to get a positive 1b? So here's how my thought, I'm going to try to show my thought process. Since I'm subtracting these, the bigger number should have this symbol. So that means the 36 needs to be positive, the 35 negative. Going backwards to get, what do I put here in front of the 5? Negative and positive. And after all of that, am I finished? No. If it had just said factor, you'd be finished. But we've got to solve this by setting each one of these to 0. How am I doing on space? Okay. And 7b. Okay, so I've got to isolate the b on that first one. 6b minus 5 equals 0. I'm going to add 5 to both sides. And then divide both sides by 6. Are y'all caught up? 5 over 6. What about here? I subtract 6 from both sides. And then divide by 7. So negative 6 over 7. So 5 over 6 and negative 6 over 7. When you're typing the answers, do not put a comma in the denominator. You have to separate the answers by commas, and it used to be if you put a comma in the denominator, it would automatically count it wrong in the homework. But someone decided to be nice. Some programmer decided, oh, I'm going to stop counting that wrong for the problems he designed. But what about the other hundreds of programmers working for Pearson? Well, they didn't correct it. So sometimes they'll take the comma in the denominator, sometimes they don't. Now on a test, in the homework, I better change that. You get it wrong, you get to redo it. But on the test, you don't. So do not just make a habit. Never put a comma in the denominator. It should go up here between the two fractions.
With negative 6, so the 7 still stays positive?
You would leave the negative.
Yeah, yes, the 7 is
Wait.
positive, the 6 is negative. If you want to type it like this, just with the negative in front,
It'll still be the same.
yeah,
Yes.
that's probably the preferred
That's what I
way,
write it.
but the lazy man way to do it would be put the minus up in front, I guess.
You're saying Pearson won't accept it if it has a.
They would take it if you have it in front. I bet you they'd take it if you put positive 6 over negative 7. Negative divided by positive is negative,
Okay, type that in.
or positive divided by negative is negative. I bet they would take it, but it's still bad practice. Generally, you do not leave denominators negative. If they're both negative, negative divided by negative, then the fraction's positive. If the fraction is negative, either write it in front or put it in the numerator. And I'm not going to type it like that with the negative in the denominator just because it's bad practice. Now, what am I typing?
5 over 6.
5. Oops. I forget sometimes to just hit the little slash bar rather than using the hot button. But
You see, don't put the comma right now. Hit the
look what I did. I just hit that comma. It's in the denominator. You don't want that.
It might count it wrong if you do. It might not, but sometimes it does.
And then the homework, you can correct it, but not on a test. So, comma, and then we have the little fraction hot button. I'll put the negative 6 on top. I could have put the negative in front if I'd wanted to.
Okay. Now, I just jumped around to do examples. You go straight through, okay, to them. I just didn't do one like every, single one of these, because it is sort of repetitive. The first 2 lectures during the semester, I do every one of them. At this point, we're looking through strategically deciding which problems were the best examples for the subject, and those are the ones we chose. So, are there any questions?
Okay, I'm stopping the recording.